In this video, we will be exploring our model's design space using Simulink Design Optimization's sensitivity analysis tool. Our model consists of a full-bridge rectifier to convert a 60 Hz AC supply into a direct current supply. The rectifier output is smoothed using a capacitor and then amplified using a non-inverting op-amp. Our objective is to determine which model parameters impact the rise time of the output voltage waveform and its maximum value the most. Open the sensitivity analysis tool from the analysis menu. Open the Select Parameters dialog to create a set of parameters to vary. In our case, we are interested in seeing how changing the value of the smoothing capacitor and the amplifier resistances affects the rise time and the output voltage. The next step is to define a sample set which describes how the capacitance and resistance values vary. You can generate a regular grid of samples by specifying the possible values each variable can take, or generate them using Monte Carlo sampling. When generating samples, you can specify the probability distribution they are drawn from, such as a uniform distribution or a normal distribution, and the properties of this distribution as well, such as the minimum and maximum values, or the mean and standard deviation. In our case, let's assume that all the parameters are distributed uniformly and define the minimum and maximum values they can take as shown. We then generate 100 samples and create a scatter plot to visualize the set. The diagonal plots are histograms that reflect the distribution of the parameter values, while the off-diagonal plots are scatter plots for each pair of parameters. Now, define the maximum voltage requirement we are interested in. This requirement will help us see which model parameters have the largest impact on the output voltage value. Create a signal property requirement in which we want to minimize the maximum value of a signal. In this case, the signal we are interested in is a load voltage. To check the rise time, we need to create a custom requirement. We want to minimize the rise time, which we calculate using a custom rise time filter function. The custom requirement uses information from the load voltage signal previously specified. The rise time filter function uses the step info function from the control system toolbox to return the value of the rise time as shown here. Now, evaluate the model to see how the maximum voltage and rise time values change over the sample set. A scatter plot is created in which you can see how the voltage and settling time values change with each sample. We can clearly see a trend in which the rise time increases monotonically with an increase in the capacitance value. We can also see that as the value of the resistance R1 increases, the output voltage decreases, and the opposite happens with R2. We can further analyze these results by computing different kinds of statistics such as the correlation and regression values using raw and ranked data. This generates a tornado plot for each requirement, in which the parameters are sorted by the magnitude of their influence. From these plots, we can see that the capacitance has the most influence on the rise time as expected, with an influence value close to 1. Similarly, the maximum voltage value is directly proportional to R2 and inversely proportional to R1. This is in accordance with the gain of a non-inverting op-amp, which is given by R2 plus R1 over R1. This concludes the video.